Hello. So this time we still on section 6.2, chapter 6, section 2, part 2. Part 2 is about finding the volume of rotation using the washer method. So we already made videos on case 1, case 2. So now we're going to make the video on case 3. Okay, so again, case 3. So let's just talk about the region. We see the region is given, the region R is bounded by the function x equals f of y, which is this curve, and then x equals g of y, which is this curve, and y equals c is this horizontal line, and then y equals d is this horizontal line at d, and then c. So as you can see, C is less than D, so C is lower than D. F of Y is greater than G of Y. So this is X equals F of Y, and that is X equals G of Y. And so this data creates this region. And then the rotation is respect to the y-axis. So we put those curve arrows around the y-axis to mark the rotation. So you're going to rotate this region 360 degrees with respect to the y-axis. And then uh, the line of rotation for both disc and washer is always perpendicular to the cross-section line. So that's why the cross-section line here have to be horizontal, because the line of rotation is already vertical. So within the given region, we're going to draw the cross-section line from one end of the region to the other end of the region. So if you project this line, it's going to hit the y-axis at y. So that means that everything that you do here must be expressed in terms of y, including the integral that you're going to set up is going to use the variable y. So when you look at this region is bounded below by y equals c, and above by y equals d. So these are those are our limit of integration. Okay, we're going to integrate from c to d. Now let's find the radius. So the inner radius is the distance from this end of the cross-section line to the line of rotation. This distance is, at this point, the function is a g of y, and here its x-axis, y-axis, its equation is x equals 0. So you're going to have a g of y minus 0, which just gives you g of y for the inner radius. The outer radius is going to be the distance from this point to the line of rotation. At this point, that's the function f of y minus 0. It gives us f of y for the outer radius. Now that we got these two, where we go to step 1, we write them down. The inner radius is g of y. The inner area is going to be pi times g of y squared. The outer radius is f of y. The outer area is going to be pi times quantity f of y squared. The area of the washer is the outer area minus the inner area. This is the outer area. That's the inner area. So you take the difference, you factor out pi, you get the integral from c to d of pi times quantity f of y squared minus g of y squared dy. Okay, so that's the concept. So let's do an example. You have they give us the region that is bounded by x equals y squared and x equals 2y. No limits are given. We're going to find that. The rotation is about the y-axis. So when you graph x equals y squared, you have this curve, and x equals 2y is just a straight line that goes through 0, 0. Okay. So the two give us this, we give us a common region. I mean, a region bounded by the two curve is the one you see, the shaded region here. And the rotation is respect to the y-axis, so we mark the rotation. Now we know because the rotation, the line of rotation is vertical, then we know the cross-sectional line will be horizontal. So here's our cross-sectional line. When you project this, it's going to touch the y-axis at y. So everything must be expressed in terms of y. Now we already have the two curves already expressed in terms of y. We don't have to worry about the curve because it says x equals 2y and then x equals y squared. All we need to do now is find the point of intersection, okay, which will give us the boundaries, the limit of integration. To find the point of intersection, there's two of them. This one we know already, it's 0, 0. But this one, what is that? So to find it, we'll have to set the two equations to be equal. So we're going to set the 2y equals y squared, or y squared equals 2y. So subtract 2y from both sides and then factor out y, and then set y equals 0 and y minus 2 equals 0. So that gives us y equals 0 and then y equals 2. So that gives us our limit of integration. This is a 0, y equals 0, and at this point, y is a 2. So when we write the integral, it's going to be from 0 to 2. Okay, so we go and find the inner radius, which is a point from, this is the cross-sectional line. So the inner radius is this point to the line of rotation, which is basically the function itself, y squared. So that's the inner radius. The outer radius is at this point to the line of rotation, which is just a 2y minus 0, which will give us 2y. So again, step 2, we copy down the information. The inner radius is y squared. So the inner area is pi times y squared squared, which is pi times y to the fourth. The outer radius is a 2y. So the outer area is pi times quantity 2y all squared. You get, so when you square 2, you get 4. You square y, you get y squared. The area of the washer is the outer area minus the inner area. So this is the outer area and that's the inner area. We take the difference, we factor out pi, we get 4y squared minus y to the fourth. We go to find the volume. We already discussed how we got it 0 and 2. So we're going to integrate from 0 to 2 times. We will integrate the area of the washer. So it goes here. Now, we can factor out pi because it's a constant, and then we find the antiderivative of 4y squared, which is 4y cubed over 3, minus the antiderivative of y to the fourth is y to the fifth over 5, and then we can evaluate this at 0 and 2. First, we plug in 2 for y, and then minus, we plug in 0 for y into the expression, then it gives us everything 0. So we end up with 2 cubed times 2 squared, it gives us 2 to the fifth over 3 minus 2 to the fifth over 5. So 2 to the fifth is a common factor, you can factor it out. You get 1/3 minus 1/5. Find the common denominator, which is 15, and then you end up with the numerator to be 5 minus 3. So you get a 2 over 15, and then times 2 to the fifth. So 2 times 2 to the fifth, it becomes 2 to the 6. Then times pi over 15. 2 to the 6 is 64. So get 64 pi over 15. Thank you.